There are a few more things I want to show you about the Meandering River. Okay, so this is a stratigraphic column on a log sheet, or we call this is stratigraphic log sheet. So the log sheet including several columns I want to explain to you because this is what you're gonna use in one of the labs. Okay, so on the first column is the scale. The scale has marks. You need to mark the thickness of the stratigraphic column with a proper scale. And then the second column is lithology. In lithology, you're gonna use patterns to distinguish different lithology. For example, this is a sandstone, and this is sandstone with gravel, and these are shales, and with sandstone, interbedding with the sandstone. So these columns are only using patterns to differentiate different lithology. On this column, with thinner lines, it is using these lines to differentiate the texture, which is the grain size. So if you look carefully, actually there are two types of lithology: limestone and siliciclastic sedimentary rocks. So if the rock you're logging is a limestone, then you need to use these lines to represent different types of limestone. This is mud, wacky padstone, and a grainstone. And this is a boundstone. And if it is siliciclastic sedimentary rocks, you use this to represent different, like clay, silt, very fine sand, fine sand, medium sand, coarse sand, very coarse sand, granular, pebble, cobble, and a boulder. So these lines represent grain size. The larger grain size it is, the wider the column will be. So if a meandering river stratigraphic column is drawn over here, then you will see the finding upward trend from here, reflecting from here as well. And within this column, you need to use patterns to show the stratigraphic structures. Stratigraphic structures such as planar crossbeds and ripples and laminations. Okay. So this is how you use a log sheet to draw a stratigraphic column, and this will be provided when you are doing one of the labs, and you can use this to draw hundreds or tens or hundreds of meters of stratigraphic succession using proper scale over here. Here on this side, it shows a stratigraphic column of a meandering river. So this shows meandering river channel meanders back and forth like this, and there's some crevasse splay deposition as well within the floodplain deposition. So you can see that the channels are every time when it meanders back, it cut into the floodplain deposit, and the channel and the floodplain they're alternating beds. And another thing you can see is that within the channel deposit, there is also a finding upward trend. Okay. Here I want to show you that this is a plain view of a meandering river valley, and this is the active channel, area, and this is the floodplain, which is the river valley. So compared to the river valley, the active channel actually is only occupying a small portion of the valley. Another thing is, so when the river active channel meanders, actually they are cutting in the floodplain area, and this is what you see in the geologic record as well. So that's why all these channels on the in the cross section, they are not connected, and they here they're looking just channels within floodplain deposit. Looks like this, and that's why in the stratigraphic column we always see channel deposit and then come back with the floodplain, and then the channel meanders back and then meanders away. We have a floodplain deposit. And as you can see, the river valley is really large compared to the active channel, and these area will be flooded during floods. And the floods are actually not very often that the entire valley will be flooded. So human beings start to build houses in this river valley. For example, Arlington Six Flags actually is building on a floodplain. Another thing I want to show you is you need to remember this word, avulsion. Avulsion is when the meandering river abandons the old river channel and creates a new path. So this action causes avulsion.